Neat uranium, the world's most dangerous metal. This heavy silver-gray puck sits silently in a sterile lab, far heavier than it looks. The world's most dangerous metal. This heavy silver-gray puck sits silently in a sterile lab, far heavier than it looks. A single puck like this weighs far more than you expect. Even advanced robotic systems measure its extreme density with care. One tiny uranium pellet contains more energy than an enormous pile of coal. That single fact changes everything. Contrary to what movies show, uranium metal is not green and it does not glow. It is dull silver gray, just like this. Left exposed to air, uranium slowly darkens as it oxidizes, a quiet visual warning of its reactive nature. Every sample is carefully sealed and labeled. Safety and traceability begin the moment the metal is handled. Uranium is never found as pure metal bars. It hides in tiny specks inside ancient minerals and rock. From the lab, we move to the remote operations center, where the long hunt for uranium deposits begins. Core samples reveal dark streaks of mineralization. Instruments confirm the presence of uranium deep within the rock. Heavy, secure doors close. The transition from discovery to industrial processing is now complete. The sealed sample begins its journey, moving through clean, automated corridors toward the next stage. Radiation levels around the container remain low and stable, a calm reminder that controlled uranium is manageable. Here is the full nuclear fuel cycle: mining, milling, enrichment, fuel fabrication, and finally, safe storage. Natural uranium is silver gray and never glows. The myths are powerful, but the reality is far more disciplined. From this small puck comes enormous potential. The sterile lab door opens to the raw earth where it all begins. Modern open-pit mines operate with precision and automation, carefully extracting ore while controlling dust and impact. Underground, powerful drills bite into the rock face under strict safety protocols and dust suppression. Blasted ore travels on covered conveyors where automated systems scan and monitor every fragment. Inside sealed crushing halls, ore is reduced to smaller pieces under negative pressure and full containment. The crushed material enters grinding mills, turning into a fine slurry ready for chemical separation. In leaching tanks, carefully controlled chemistry begins to dissolve and release uranium from the rock. In situ leaching uses underground wells to dissolve uranium without massive surface excavation. Ion exchange columns quietly capture the uranium from solution with remarkable efficiency. Through precipitation, the uranium forms a bright yellow slurry, the first visible sign of concentration. The yellow solids are filtered and separated, becoming the first tangible product of the milling process. The yellowcake is gently dried in sealed rotary dryers under precise temperature control. Dried yellowcake powder is automatically filled into heavy steel drums with exact weight verification. Each drum is carefully sealed and inspected to ensure complete containment before leaving the facility. Robotic systems palletize the drums and wrap them securely for safe transport to the next stage. The sealed pallet moves through airlocks, leaving the milling world and heading toward conversion. Natural uranium contains mostly U-238, with only a tiny fraction of U-235, the key isotope for energy. Sealed drums of yellowcake arrive at the conversion facility where they enter closed processing lines. Inside secure equipment, yellowcake is converted into uranium hexafluoride gas under strict containment. The UF6 is loaded into specially certified cylinders designed for safe transport and handling. These heavy cylinders are moved through multiple security layers toward the enrichment halls. Inside the enrichment hall, rows of sealed centrifuges spin at incredible speeds in total silence. Through thousands of cycles, the slight difference between U-235 and U-238 is gradually increased. Every step is monitored with tamper-proof seals and continuous safeguards inspections. Once enriched, the product is carefully sealed back into cylinders under robotic precision. The enriched cylinders now leave the science stage and move toward fuel fabrication. Strict airlocks and scanning portals maintain separation between enrichment and fabrication zones. Low-enriched uranium is used exclusively for peaceful civilian power generation under tight regulation. The massive centrifuge hall slowly fades as we prepare for the final material transformation. Every batch transfer is digitally signed and documented before moving to the next controlled area. The cylinders reach the fuel fabrication threshold, where gas will become solid ceramic fuel. Inside glove boxes, UF6 is converted into fine black ceramic uranium dioxide powder. The powder is precisely metered and pressed into small, dense fuel pellets. These green pellets enter high-temperature sintering furnaces to achieve final density and strength. After cooling, each sintered pellet is carefully inspected for perfect size and surface quality. Centralist grinding brings every pellet to exact dimensions using closed-loop coolant systems. Finished pellets are dried, sorted, and loaded into precise stainless cassettes. Robotic systems carefully load the pellets one by one into long zirconium alloy tubes. End caps are welded onto the tubes with automated precision to create sealed fuel rods. Each rod undergoes rigorous helium leak testing to guarantee absolute integrity. Qualified rods are assembled into large fuel bundles, the heart of a nuclear reactor. Every completed fuel assembly receives a final geometric inspection before release. The finished assembly is placed into a protective transport sleeve and securely sealed. The sealed assembly moves through final radiation checks and security checkpoints. All documentation is digitally signed, and the assembly is officially logged as complete. The fabrication bay falls quiet. The journey from rock to reactor fuel is now finished. Even pure uranium metal is far less radioactive than most people imagine when properly contained. The greater danger comes from its chemical toxicity, not from Hollywood-style radiation. After use, spent fuel is stored underwater in deep pools for cooling and shielding. Eventually, it moves into massive dry storage casks engineered for centuries of safe containment. Back to our original puck, now carrying the full weight of the nuclear fuel story. A handful of uranium fuel can power an entire city for months, replacing mountains of coal. One tiny ceramic pellet holds energy equivalent to tons of coal, a staggering contrast. Every stage demands layered safety systems, training, and constant disciplined attention. The rule is simple: handle with respect. Maintain strict contamination control at all times. This ordinary-looking metal carries extraordinary power and extraordinary responsibility. From mining to used fuel storage, the entire cycle is carefully designed and tightly regulated. It all begins with a handful of rough ore pulled from the earth. From dirt to energy, a transformation that powers our modern world with remarkable efficiency. Every journey ends the same way: secure containment and unwavering respect for the material. The story of uranium is complete. What remains is responsibility and the quiet power of knowledge.
This video is made only for education and information purpose. All visuals, scenes, and content used are conceptual, recreational, and artistic interpretations based on public available information, news, reports, and open source intelligence. Also, AI intelligence also used for better documentary. No classified, secret, and restricted information has been used in the production of this documentary. This video does not represent actual footage from any real military facility or any nuclear site.